Carbohydrates are organic compounds comprised of carbon, hydrogen and oxygen. As a nutrient, they can be classified into two major groups, simple carbohydrates and complex carbohydrates. One of the simple carbohydrates include monosaccharide, which also called simple sugars. They are the simplest form of sugar and the most basic unit to build more complex carbohydrates. They are usually colorless, water-soluble, crystalline solid and have a sweet taste. Some of the examples of simple sugar include glucose, fructose and galactose. We can find this type of sugar in food like honey, fresh or canned fruit, flavored yogurt, and manufactured food like juice.
Hi, I'm ALYA. So first, did you guys know about the D and L isomers? Let me explain about it. At first, we have to know what is the definitions of D and L isomers. So D and L isomers is categorized under the stereoisomerism. They both fall under the structural aspects of monosaccharide. When a compound has same structural formula but different spatial configuration, they are defined as the D and L isomers. It depends on the arrangements of hydrogen and hydroxyl groups penultimate on the carbon atom in a monosaccharide. Now, let's go deep into D and L isomer difference. For D isomerism, the hydroxyl group of the bottom chiral center will point on the right side, while the L isomer, the hydroxyl group of the bottom chiral center is on the left side. For the rotations of the planes of polarized light, the D isomer will rotate clockwise, while L isomer, it will rotate anti-clockwise. And for your extra information, the D isomer sugar molecule is abundant in nature compared to the L isomer sugar molecule. Okay, let's take a look on the example given. At first, you can see on my right side, the hydroxyl group attached to the chiral carbon is on the right side. This will conclude that it is a D isomers. Okay, let's move on to my left side. It's clearly seen the hydroxyl group that attached to the chiral carbon is placed on the left side. As I said before, if the hydroxyl group of the bottom chiral center is placed on the left side, it is fall under the L isomers. A simple way to understand what is D and L isomer is that you have to remember when a molecule is written according to a Fischer configuration, you have to look on the second carbon from the bottom. When the hydroxyl groups on the right hand side, it is called as a D isomers, and if it's on the left side, it called as L isomers.
Moving on to the next part, which is optical isomerism. Optical isomerism is present due to asymmetric carbon. When a beam of polarized light is passed through a solution of an optical isomer, it rotates either to the right or to the left. The rotation to the right we call as dextro-rotatory, which is positive, while the rotation to the left is called levorotatory, which is negative. The direction is independent of stereochemistry of the sugar, which may be designed as D negative, D positive, L negative or L positive. The measurement of optical activity is done by an instrument called polarimeter. This figure shows the rotation of polarized light by an optically active solution.
Hello, my name is IMRAN and now I'm going to explain about another type of isomer in monosaccharide. Epimers is a compound with the same molecular formula but a different in the special configuration of the attached group around the single carbon atom only. As we can see in this figure, D-glucose and D-mannose both have a different result. Variation of OH and H on the carbon atom 2, 3 and 4 are known as epimers. Next, I'm going to explain about the aldose, ketose, isomer, and also anomers. Monosaccharide tends to exist in the ring form, which causes the ring structure of an aldose. The ring can open and reclose, allowing the rotation to occur. In alpha anomers, the rotation of the OH towards the right side and the beta anomers towards the left side. For aldose ketose isomer, it is a compound with the same molecular formula but different in the nature of functioning group are aldose ketose isomer.
My name is Muhammad. To conclude, I will tell you about the difference between D and L configuration and R and S configuration. This is for D and L configuration. The D and L notation is applicable only to configurations of molecules that are represented in feature projection and to only one center that is written with the highest oxidation form of carbon at the top and lowest oxidation form of carbon at the bottom. Usually, carbohydrates and simple amino acids are given D and L configurational names. Now, we move to the R and S configuration. The R and S configurational notation is a general terminology applicable to all chiral centers, not only of carbon-centered chirality but also of other atom centers like nitrogen, phosphorus, silicon, or any other tetravalent atom. The R and S configurations are determined using Can-Ingold-Prelog sequence rule. The Can-Ingold-Prelog sequence rule is a substituent with a higher atomic number takes precedence over a substituent with a lower atomic number.